Greetings, my legions of 3.1415927 followers. Yes, we are making progress with the Barney amplifier. And Pilaf is here to assist, aren't you, Pilaf? Say hi to everyone, bub. You want to say hi? Okay. Anyway, so where are we at with this thing? Well, as you can see, I've got the power supply board screwed back down. I would lift it back up to show you the work I did under there, except lifting it up it puts a lot of wear and tear on it. For one thing, you don't want to, these electrical connections here with these screw mount capacitors are, every time you tighten them down, you're tightening down on the circuit board. It's a good strong circuit board, but those traces aren't infinitely thick, and you don't want to chew them up any more than you need to. And also, some of these transformer wires here are actually solid single conductor wires coming straight out of the transformer with some sleeving over them. The two center taps, which went right through here, actually broke off, and I repaired that. I could have just, there was enough length left over to just strip it back a little and poke it through and resolder it, but I don't like doing that because it's the same problem's going to happen later. So instead, I've soldered on a piece of nice high quality stranded wire and soldered that to the transformer wire. Put some couple layers of shrink wrap over it and put a little extra length in there. So now, at least when you lift this thing up, it won't be the one that broke. It'll probably be the ones that haven't broken yet. That will go. But anyway, that's all fixed now. But what was wrong with it? Let's take a quick look over here. I'm going to put the phone in my clunky little pan of ice mount here so that you can see my horrible handwriting. And well, I'm not writing love letters here, am I? So let's take a look. When we went down the power supply, the plus 50 rail was missing. It was 2.9 volts. Plus 20 rail was fine. The plus 10 rail was fine. The negative 10 rail was positive 1.3. And the negative 20 rail was positive half a volt. And the negative 50 rail was fine. So I had some suspects. I went down and started testing parts, and we wound up with one bad transistor, which was Q1 on the schematic, and we can take a look at the schematic later. This is it right here, 2N4036, and that is blown. The other thing that was very bad, and it took me a while to figure it out, but there was a very, very leaky capacitor in there. This 100 microfarad at 16 volt capacitor, which was on the same driver board that smoked the resistor. So let's take a look at that driver board now. So here's that driver board now, and I've replaced the blown resistor with a carbon comp 5%. The original was a 10%, so this 5% is fine. Why won't this focus? There we go. So what else did I do here? I also replaced all of the electrolytic capacitors. Well, you might notice that there's one missing off this board right now. That is a non-polarized 100 mic at 6 volt electrolytic that is also leaky. That didn't cause the meltdown here, I don't think, but so what did we have? We basically had we also had a capacitor up here on this board that was leaky too. And so it's possible, in fact likely, that this 100 ohm resistor smoked because of one of these capacitors being completely leaky, like dead short almost. So the good news is that I was able to find replacement capacitors that are the exact replacements, and these are the original 1972 Sprague capacitors here, 7239 date code. And these are the brand new Sprague capacitors. Same series, 30D series capacitor, same spec, same size, same ratings, but most importantly, a modern date code. These were made 2103, so third week of this year. So nice, fresh capacitors, and I'm very, very pleased. That basically, here's all the old capacitors out of this amp, most of the old ones anyway. I'm very pleased at this restoration, that I'm able to find the exact replacement part that, you know, not only is electrically correct for this circuit, but actually looks the same and is the same manufacturer and same series of capacitor, and they're available 50 years later, and they look the same. That's pretty cool and amazing. I hope to have as much luck with the non-polarized capacitors, which are proving very difficult to find right now. At least the Sprague 30D series are. So these are the two non-polarized 6-volt capacitors. There's one on each of the driver boards. I'm still trying to find replacements for these. But we've got the rest of the amp recapped. And so on the subject of bad capacitors, let's tilt up here, and you'll have to pardon the clunkiness, but I think you'll agree that my little desk pan of ice mount is probably a little less annoying than when I handhold the phone. I think we can all agree on that. So let's see here. So I got a handy dandy new little ESR or LCR meter that does ESR as well. And let's take a look. I got a couple ways to test capacitors. And let's take a look at what these bad capacitors look like under a variety of different test methods. So let's start with the one that I think that absolutely smoked the resistor on this driver board over here. And let's hook it up, observing polarity. I'm not sure if the camera's got me putting this thing in the test clips, but you know, let's see. I'll try to getting the focal distance I need, as well as keeping this thing from falling off the bench. One of these days I'll buy a GoPro, but when my videos get like 50 views each, I'd rather spend that money on a tool like this. Anyway, let's see. So if we put it on auto, let's turn it off, turn it back on, so it just goes back into auto mode. There you go. It's treating it as, it's detecting it as a resistor. 0.038 ohms. Yeah, that's not good. So let's force it into capacitor mode, so it actually tests it as a capacitor, even though it's obviously so leaky. It auto detects as a resistor, and nothing. We get overload. We don't get any of the ESR or any of those values. This capacitor is just completely shorted, right? So how shorted is shorted, right? Like, how much current would this thing pass? Would it pass enough to smoke a 100 ohm resistor? Well, we have this other capacitor tester over here, which allows me to test at up to 800 volts, actually. It's a pretty nifty little tester, although having looked at the inside, the way it's put together, I'm not sure I'd recommend it from a quality standpoint. But let's hook up, well, first let's dial in the source voltage. This is a 16 volt capacitor, so we definitely don't want to test at 48 volts. Let's go down to like, I mean, this thing was on the 10 volt rail, right? So let's just put it like, yeah, let's put it like right there. Actually, you know, now that I think about it, this 16 volt capacitor is not the one off this driver board. The one off this driver board is a 50 volt capacitor. This is another shorted capacitor. This came off the underside of the power supply board. This one was the capacitor that was filtering the output of the negative 10 volt rail, and it was bad. And this is the reason the negative 10 volt rail failed. Anyway, let's take a look at that. Take a look at that one. So that would have been like, I'm not sure which C number that was on the schematic. But so let's go ahead and test this thing. And so this meter maxes out at 10 milliamp current, and as you can see, that's what it's showing as the leakage. It manages to pull the source supply from like 12 down to 8 volts. Let's see what kind of voltage is actually present on the capacitor. 1.6 volts. So it's pulling 10.9 volts all the way down to 1.6 volts, and that's current limited. Without that current limiting in this thing, you know, this would probably go up. So that's what a very badly shorted capacitor looks like on two types of testers. I like to use this type of tester, or, you know, apply voltage to a capacitor and look for current. You know, you can do that with, you can make a current bridge or whatever and measure that with other tools if you have a power supply. But basically, you need a variable power supply that goes to whatever voltage you want, and you need a way to measure a current across the capacitor. And then you just have to kind of factor in how large the capacitor is to give it enough time to charge up before you start really watching the current too much. Now here is a 50 volt 50 microfarad capacitor. That was the majority of the capacitors in this amp. There were 8 of them. So let's dial this one up and test this one at 50 volts. Now, it looks okay, right? Like the leakage is going way, way, way down as the capacitor charges up. It's very low. Okay. Yeah, it's almost, the leakage is almost down to nothing, right? We can compare, I've got a spare new capacitor here. Let's compare this, you know, which we'd say that pretty much passed the leakage test, right? Let's take a look at what a brand new one does. As you can see, as it charges up, leakage goes down. If you haven't used the capacitor in a while, it takes a little bit for it to form back up. And as you can see on this new one, at the moment the leakage current is higher than what we got out of the old one. But this new one's been sitting on a shelf for a long time, hasn't had full voltage applied to it in a long time. So as it sits here, you will watch as the leakage current goes down and down and down and down. And I wear out my thumb holding it here long enough, but I can bet you that eventually, if I hold my thumb here long enough, it'll get down to as low or lower than this one. Okay, so, but again, you know, if you haven't used a capacitor in a while, if it's not formed up, well, this one looks like it's bottoming out right here. Now, see, it's still dropping, but just very, very slowly. All right, you get the point. So let's take that one out, and let's hook that one. Let's hook this new one. Yeah. It's telling me it's timing out. Okay, so let's hook this one up. Let's see what kind of readings we get here. Okay, so 50.6 microfarads, so very, very close to the original value. Q factor of 4.47, an ESR of 0.7 ohms. That's actually a little bit higher than most of the ones that have these, the new ones that I've checked. Most of them are almost bang on half an ohm. This one is negative 77.3 degrees phase shift. Okay, so you kind of get the idea of the values we see there. Very, very close to the original value on capacitance. Low ESR, almost 80-degree phase shift. Okay. Let's take a look at this one that we pulled out. This 1972 one. I don't have a black X on this one. We might be testing a good capacitor here, but let's see. Ah, look at that. it shows up as 1.6 picofarads. Now, what might be going on here is there might be a little bit of charge left on this capacitor that might be flummoxing the meter. So I'm just going to short this capacitor out real quick across the lead of that other capacitor. Let's try that again. There we go. Now we're getting a reading. 51 microfarads, an ESR of 0.7 ohms. Phase shift negative 76.9. Q of 4.3. So we see this capacitor here has very, very similar readings to a new one. Still probably within spec, but nevertheless, when you start finding other ones, like here is another 50 at 50. Let's test this one out on the meter and see what it says. 53.5. Now this is interesting to notice how this one has drifted up in value a little bit. Now you wouldn't think that that's out of spec. Maybe by the sheet it's not out of spec. But when I just took 10 out of these out of the bag and they were all almost exactly 50, like 50 or 50 and a half. And this one is climbing up a little bit. And that could be concerning. That could mean that it's drying out, that the capacitor is shrinking and the space between the electrodes is contracting, and that's what's causing the capacitance to go up. Let's take a look at the ESR. See, the ESR is at 0.87. Again, not very high, but I just took 10 of these out of the bag, and other than the one we just checked, they were all bang on half an ohm. And this one, you know, not quite double that. The phase shift is slightly less on this one too, negative 73.5. All the ones I'm testing out of the bag are like 80. So this one is just very subtly starting to show its signs of aging on this meter, right? Well, let's try a leakage test on that same one, a 50 volt leakage test. Let's see what happens here. Let's hook that up. And yeah, it's going down pretty quick. Now you see, yeah, the leakage is dropping overall, but it's kind of going up and down and fluctuating around a little bit. Instead of just going down, it goes down, back up a little, then down a little more, and then down a little more, then back up a little, right? Probably still okay. Probably still usable, but definitely showing some signs of not being new, right? Let's see, what else do we have here? I feel like I had another one of these 50 volters that was really leaky, but I may have lost it in the shuffle. Let's see about this one. No, this one's not terribly leaky either. This one climbs down pretty good, but still, you know, again, going down and back up, down and back up. Borderline, right? What else do we have? We have one more. Did I already do this 100 at 16? Yeah, we did that one. Ah, now our poor non-polarized friend. Well, someone's got a question mark on it. This one, though, is definitely bad. Let's take a look at what that one does. So we're going to dial the voltage way down for this one. Let's test it at like 4.5 volts. It's a 6 volt capacitor. So, non-polarized, right? We can hook it up any way we want. That's the theory. So let's give that a test. Oops. Look at that. 6.2 milliamps of current at 4 volts. But it's pulling it down, pulling the source down to 2.5, and the voltage at the thing is only 0.3, 0.2 of a volt. So obviously extremely leaky. Now let's take a look. Since we know that that's what a leaky capacitor, this non-polarized, looks like on the voltage leakage tester, let's test it on the old capacitor tester here. And let's start by shorting the leads. although I don't think there was any danger that that capacitor was holding any sort of charge. Now look at that. Look at that. This is a very interesting result. 204 microfarads. That's double the value on the can. And so anytime you see something that tests way higher than it's supposed to be, the first thing you can suspect with an electrolytic is that the electrolyte is drying out in the paper between the electrodes, which is making the electrodes get closer together, right? The closer together the electrodes are, the higher the capacitance, but also the higher the leakage, the higher, the lower the voltage breakdown becomes. So this thing is still testing as a capacitor. And let's take a look at, let's see, the ESR shows 0.7 of an ohm, nothing too crazy, but look at the phase shift on it. Negative 48 degrees. That's weird, right? So, I mean, the ideal capacitor is what, negative 90 degrees? And this phase shift is, just over half of that. And that's probably got to do with the way this thing's testing the capacitor. And maybe it calculates phase shift by where it catches rise time, above a certain threshold, and maybe some DC leakage confuses that reading. But that is an interesting, thing there. When you see that phase shift is so far away from 90 degrees, the capacitance is so far off from the original value, Q of 1.1. The ESR that otherwise looks okay, but we just saw this thing was just incredibly leaky. So that, unfortunately, is going to be the hard part of finding these two guys right here. These two 6-volt, 100 microfarad. There are some other non-polarized capacitors, which I think are okay. I've been testing them in circuit. It's these ones here, these big old 300 at 3-volt non-polarized that are part of the base circuit in the RIA circuit of the phono preamp. So try leaving those alone. And if these fail, it'll be a sound quality issue rather than a fireworks issue. So we'll just try those out for now. The tantalum capacitors. Now, all of these boards have tantalum capacitors on them, and the first thing you're going to say is, hey, aren't you going to replace the tantalum capacitors? Don't tantalum capacitors always go bad? And if they're the tropical fish type, like these little guys right here, the answer is, yeah, these almost always go bad. These things are horrible for their reliability. This one here is out of a pack of 4 that I took out of my old stock parts bin, and I tested all 4 of them. 2 of them tested okay, and 2 of them were completely failed. And that's just sitting on a shelf, right? So you can imagine with some use and some heat from being in an amplifier, not going to last so good, right? Well, fortunately, I've been looking through the data sheets for Sprague capacitors, and these tantalums here are hermetically sealed, and they're kind of, I don't know that they're quite mil spec, but they're if they're not, they're bordering on it, right? So these seem to test fine. I haven't applied much of a direct DC leakage test to them yet, but with this in-circuit probe, let's see if I can even do this in the same field of view. Can I get the meter and the board and get the glare out of it? Let's see here. Okay, so if I test right here, 16.2 microfarads. 14.1 microfarads. 15.8. These are, I believe, rated plus or minus 10. Is that right? Yeah, these are plus or minus 10, and the stated value is 15. So plus or minus 10 is plus or minus 1.5 in either direction, right? So 16.2 is within. 14.1 is within, and again, this is in circuit, so there might be something kind of affecting these values. 15.8 is in. 15.2 is in. Okay, and I've been testing these pretty carefully. I haven't found one that strikes me as bad yet. So maybe the good news is that these tantalums actually hold up because they're hermetically sealed. That'll be good, because these are also $5 a piece. So you figure, you know, another $20 per board for the 2 driver boards, and then, you know, a few scattered, or oh no, for the 2 phono boards, then 2 each on the driver boards. What do you think, Peel Off? Is that just too much work? Too much money? Yeah, I agree. So let's take a quick look here and see where we're at before we wrap up this rather long video, which is going to conclude with me saying, I've got to order more parts. But as you can see, I've got the driver boards all stuffed with new capacitors, except for the 2 bipolars that were missing. This guy, again, all the same Sprague 30D series, so that came out as good as you could possibly hope. So let's fire it up and take some measurements carefully. Let's turn off the capacitor tester before I zap something. And let's plug the amplifier in. Oh, you know, it's funny. You might have saw the lights flash there when the amp kicked in. I actually had this power switch off, but as I was leaning over, my leg poked it on. So, oh, side note. The speaker terminals on this thing are Cinch Jones, and you got the a lot of people have done dumb things to these amplifiers by replacing these goofy Cinch Jones speaker terminal outputs with a standard binding post, or, you know, some audio-phily gold-plated nonsense. Yeah, don't do that. Just go get the Jones plugs. They're only about $8 or $9 a piece. It's 202 SP, I think, is the model of these. You can get them at DigiKey. You can get them at Mauser. You know, get the right part. They're not expensive, and then you get to, you know, solder some cool speaker wire to them. Do whatever you want. You got a special set of cables for your Barney Oliver. Anyway, so let's take a quick look, go down our voltages real quick. Let's see here if I can do this one-handed. And then we'll just use our chassis as the ground point. Make sure my trusty Keithley is in DC mode. And power it on up. Okay, so let's see, do I have enough length here? So let's just go down the rails in order. Now we already, the 50 volt, the negative 50 was fine, and it is now negative 56, so it's still fine. The negative 10 and the negative 20 here were both missing, so let's check the negative 20, and we have negative 19.1, which is a significant improvement from half a volt positive. And let us check the negative 10 line. Wow, this is so weird, trying to use my viewfinder to actually steer my hands. Negative 9.6. So again, a significant improvement from positive 1.3. And the plus 10 rail, which was fine before, is still, oopsie, there we go. Oh, what's going on? Oh, I think I was just probing in a weird way, or I disturbed the, but anyway, yeah, 10.0, yeah, that's 10 bang on the money. And the 20 volt rail 19.96, very, very good. And our plus 50, which was missing before, is now 55.9 volts. And that was missing. Let's go ahead and turn the amplifier off and unplug it. So now we have a very good starting point. We've got all our power supply voltages back. We've replaced all of the electrolytic capacitors except the two big main ones. Now, I tested the snot out of those with that leakage tester, and as you can probably imagine, at 10 or 12 milliamps max, it took forever to charge them up. But when I did charge them up, I mean, I didn't see any leakage on them at all. Even this guy here seemed to like what it was seeing from those capacitors, and based on the Sprague data sheets, those are still in spec. They're easy enough to replace. You don't even have to take this board out. You can unscrew these and pop the caps out the top. So at 45 bucks a piece, and you know, I mean, I'm already spending 160 bucks restoring this amplifier. One could make the argument that you should just do it all at once, but at the same time, those big boys just seem to be fine. If they start to go, you'll start getting hum. You'll know it. It's not going to toast the amp, but you'll start getting hum out of it real quick. Anyway, although due to the common mode rejection in this thing, that might take a while. But anyhow, what are we doing here? One last thing. Oh yeah, so that plus 50 volt rail, that died. Well, this capacitor died right here. I mean, sorry, it's capacitor. This transistor died. Whoop. Okay, see you later. It seems to have gone out because of another leaky capacitor. So there was a leaky capacitor on the other side of that transistor, and it just pulled the rail down so hard that the transistor went kaplowy. And so that's it. You know, we've got one bad transistor. All of the transistors that I pulled out, you know, I basically pulled out all of the ones that were unaffected, you know, that were in spots where they were missing voltages. I pulled out those transistors and tested them on, you know, a little Drock transistor tester, a little Radio Shack go no go tester, and sure enough, there was only one bad transistor out of the bunch. So that's cool. That means that all of the spare ones that I ordered, I can use for experimenting and breadboarding this amp and experimenting with some of the circuits in it without actually hacking the amp. So there we go. That is the update for now. I don't think there's anything else to show you. We just got to get those non-polarized caps. Then I will have to reinstall the power transistors from the right channel that I pulled out for troubleshooting purposes, and put all the cards back in and start measuring voltages and checking bias and, you know, just doing things like that. All right. See you next time on the Barney